All right, so today we're going to continue with our algebra tiles, exploring, instead of just perfect squares like we did yesterday with the Valentine, we're going to do connect 4 around completing the square. So we're going to play a little game over there. But to start, we have this warm-up, which doesn't belong. So we've done a lot of these, but this is different because algebra tiles. Who knows or has an idea of what doesn't belong? Anybody?
Bottom right has no constants.
The bottom right has no constants? Good. How would I write this expression if I had to, Kyle? This expression, what do I have? It's not a trinomial. What is this? As far as polynomials go, it's a binomial, two terms. Great. Anybody else? Which doesn't belong? Which doesn't? Yeah.
The top right, because it's a perfect square.
Because it's already a perfect square, right? We have this one here, perfect square, already. Can you go and tell me what tell me what the tri is, the trinomial before we factor it?
X squared plus 4x plus 1.
Yeah, excellent. And when we're completing the square, we're really changing it into vertex form, okay? In this case, we have dimensions. What's the dimension here?
X plus 2.
X plus 2 in the top.
X plus 2.
Yeah, and you know it's a square, right? So you know it has to be the same at top, right? So x plus 2, yeah, the quantity, x plus 2 squared. Let's start to use that language, the quantity here. Quantity x plus 2 squared. Excellent. Who else? Why doesn't it belong? Anybody? Anybody? Oh, Jason. Awesome.
So the top left-hand one, because there's 3 extra columns.
There's 3 extras. It has the greatest number of extra constants there. Oh, constants. All right. Anybody else? What else? Yeah.
The bottom left one, because there are 2 constants.
Because there's 2, huh?
Yeah.
That's different.
There's constant in my life.
Constant in your life. That's your theme. Constants. All right, Justin, anything else?
I don't know.
Okay. Jason, your new name is Constantine. All right. Isaac.
Oh yeah, the upper left.
Okay.
Because this square and the 3 outside numbers seem to be facing each other.
Oh, they're just facing each other. Spatially, you're saying it's going in. Okay, I like the symmetry. You're noticing symmetry. All right. Can you tell me what this is as far as the trinomial goes? What tiles do we have just added together here? What do I have?
Oh, this is x squared plus 2x plus 1.
Okay, but remember we're talking about all of it before I put it into the
4.
Yeah. So we're going to go plus 4, and then go and finish it out here. What is the factored form? What's the perfect square here, the dimension?
X plus 1 squared plus 3.
Plus 3 leftovers on the outside. Okay. When we force the completing the square, we're going to end up with some leftovers, and that's where they go. This right here, this is now in vertex form. You can visualize the parabola. We know the translation with x plus 1, and then the plus 3. Think of where they would end up. Plus 3 up. So the vertex here would be -1, 3. Does it face up or down? The A usually goes out in front. It's not there, so it must be 1. Half face. Cool. I want somebody to go ahead and factor this, and then we're going to move on because these are all the same. But how do I factor this to get it close to being in vertex form? What's missing first? We can't complete the square because what's missing? Constant. What constant will we put in there if we could do whatever we want? 0. Actually, 0 isn't the way to go with it, because if I put a 0, there's no way to note what the area is. It would just be blank like that still. Justin?
1 and -1.
Why are you going to put a 1 This is perfect, I like it. And and a negative 1. What happens when
Because it balances out to 0.
the negate, right? These together are 0. X plus negative x, 0. So you can add whatever you want. I'm going to go and add that 1 here, and then I have to add negative 1 on the outside. That's one tool we're going to be using today too. When you have a gap, you can fill the gap as long as you put the positive and the negatives, and it cancels it out anyway. Because if I were to write this whole expression, what tiles I have x squared plus 2x. These cancel out, so I still have my original expression here. Justin, go and get that into vertex form. So how about this square up here?
X plus 1 is 2.
Mm-hmm. And
then minus 1.
Minus 1. See? When you have a gap, you can fill it with the positive negatives that cancel each other. Just making sure that you don't get it mixed up which goes where. These are all positive tiles, so I put the 1 on the inside. Okay? All right. What do we remember about perfect squares? Anybody? Anybody? What do we know about perfect squares? The algebra tiles make a square. Algebra tiles. And I put these tick marks just to show they're all the same. Okay. What do our expressions look like when we have a perfect square? We go from our trinomial and we factor, and we end up with thank you. That was cool. I'm going to go x plus c squared. So the quantity of x plus c squared. C is just a constant in there. You might also see it as h in vertex form. I think they give it to us as h. No worries. So maybe let's just change that up. X plus h, so that we're getting ready to think about it as vertex form. All right, so that's when we have perfect squares. When we complete the squares, what do we end up with sometimes when we complete the square? Those things on the outside, what can we call this? What do you think? I don't think there's an official term for it. We have some extra constants out there. We have constants. Remainders, we could say we have a remainder. I like that. It's going to be a constant. It's going to be a Constantine. I was thinking about writing Constantine, but that's not going to fit there. All right. Let's see. What form of the parabola does it end up in when we have this type of situation and then plus k or plus some number? Remember what form that is? What are our forms? Standard form? Vertex form? What's the other one just for fun? Factored form. Okay. Factored form. Two quantities. So we're going to go from, it's going from standard form to vertex form. Okay. So we're going to end up with vertex form. So really it just allows us to factor, and then from there we'd be able to find our vertex pretty quick. It's nice. Okay, so here's how the game's going to work. Connect 4, as you know, or maybe don't, it's no big deal. We're trying to get 4 in a row. Okay, we're going to play and select tiles, either x's or 1s, or numbers, right? X's are constants here, until we get connect 4, until we get 4 in a row. Those are going to be added up over here, just kind of placed over here, and then we're going to have to force the completed square and get the leftovers in our new expression. Okay. So the things that I need you to do on your sheet, go to put number 1, and from there, I want you to start drawing this table. Just make a table. We're going to put the x squared, which isn't one of our options for connect 4. We're going to always start with an x squared in the top left. The three things that I need to see for this is I need to see the original trinomial. I need to see the vertex form. So that's just when we factor it. And we got to see the algebra tiles configuration. So we're going to have the trinomial, the vertex form, and the tiles. So I'm going to go ahead and just pretend we got connect 4 right off the bat. Let's say we got connect 4. Oh, the other thing as well, because this is just practice getting used to it for algebra tiles, and we can't do decimals with algebra tiles. If we end up with, say, over here I'm adding up my x's and my 1's. If I end up with 3 x's, it doesn't actually work out to make the completed square. So that's where, if we end up with an odd number, we're just going to round up. Okay. So let's say if we have 4 x's and we had 5 1's. Go ahead and with your algebra tiles, get them out. Make sure that the reds are facing down, because we're going to deal with positives right now. Remember, the negatives are all in red. So let's go ahead and get out your tiles. You have the x squared to start. We have 4 x's. We have 5 1's. Go ahead and position those out, force the completed square, and then what's left over. So there's 4 x's, 5 1's. All right. Yeah. You. Oh. Anybody else not have any? Because. Okay. So last period, we didn't leave them on the desk. You guys can leave these on the desk at the end of the period. Okay. Somebody who feels pretty confident, go ahead and let me know, where should I put these tiles? How about the 4 x's? Tell me where and why. What do you think? Lawrence? Living.
2 on the top.
2 on the top? And?
And 2 on the bottom.
Okay. What was the reason for doing 2 and 2? Could I have put 3 over here and 1 over here? I could have, but I'm looking to make a perfect square. So the branches with completing the square, the branches are going to have the same number of x's on it. That's how we're going to make the square. A rectangle we'd make if we position them different. Okay, who's going to help me out with those 5 1's? Anybody? Thursday. Constantine, help me out.
The one, right, yeah.
And?
And then the one on the side.
I like to make it kind of off the corner there. Okay. So we just did the algebra tiles. We knew the original from all this. The original was x squared. We had 4 x's. We had 5 1's. Now we have to get into vertex form. So let's see, Jason, go and pick somebody else. Who's gonna get us into vertex form? Sylvan. Okay. Go ahead and tell me what the dimension is on the left side here.
X plus 2.
Mm-hmm. Because it's a square, what's this going to be up here?
X plus 2.
Good. Okay. So how do I express x plus 2 and x plus 2 here? How should I do it over?
2 squared plus
X plus 2 squared plus?
plus 1.
Plus 1. Okay. So we had the algebra tiles, we had the original trinomial, and we had the vertex form right here. How quick is that? Do you remember algebraically how tricky it was? You take the b value, divide by 2, you square it, you move things around, all this. If you can start to visualize, again, the next step, test yourself. See if you can think of a quadratic in your head. And can you put the tiles around and spatially kind of think about it. Okay? It takes a lot of visualization, but if you can do that, you're going to get these really quick. You won't even need a calculator. You won't need a factor. Just visualize the tiles. Okay? So we're moving that way. We're moving that way. All right. Go to put number 2 on your paper after you get this first example down for you. And let's see, Sylvan, I need you to pick somebody to throw our first connect for. All right, you can stand up or you can stand back there. So go ahead and Go for it. Nice one. All right. So we got a 1. So this is how we're going to keep track of them. This is going away. We're going to start with the same x squared in the top box. So get number 2 set up with this exact setup here. So we're all uniform. And then we got 1, 1, 1 so far. Okay. All right. Let's see. Kyle, pick someone else.
0.
Who? Like. Yes.
He was right. He was right.
That was close to 2x? Yeah. So we have 2 x's, we have 1, 1. Okay, Malik, pick someone else. Danny.
Why you not look at me though? That's what it was.
Danny. You threw me off.
No, where are they going?
I might call you Daniel. Sorry. Danny.
You call me Danny? I don't like that.
Okay.
I did not mean for that.
Why don't you stand up and come over here? You
Let
okay?
somebody else do it. Let somebody else.
Okay, because it's Christine. All right, Eric. Wow. That happens. Hey, that's happened before. It's okay. It's all good. All right, Eric, go for it. Boom. All right, we got a 2. Let's go ahead and add that right here. We got 2 more ones. All right. How about the anyone from the front of the room? Because the back is hard to even hit. Anybody right around? Right around you? Yeah, exactly. Go for it. Okay. 3 more ones. Get a lot of ones in here. 1, 2, 3. All right, Zach, pick someone else.
Mike.
She says no. It's yes. All right, you can stand up if you want. You're kind of from the angle there.
You have to have 4, right?
Yeah, we got 4 in a row.
Oh my god.
That was
I was
another
aiming
one.
for the X.
Oh, that's okay. Take over if you hit the same one twice. You can do it. You're good at hitting the ones that we already have. Yeah, okay, that's a good one. Look, that gets us closer. All right, we got another X. Woo! Pick someone else right near you. Really?
Really make it as big as possible.
Get
Get like a 4x.
Yeah.
No, because
Ooh, that counts.
William, don't end it.
Don't end it. One, get block out to get all. All right, who's next?
Jonathan, don't end it.
Don't end it. I think that was going over here to 5. It's closest. 1, 2, 3, 4, 5. We got 12 ones already. Who's next?
Patricia.
Oh, shoot. Where is it going? Wait, Patricia. No. Who?
Patricia.
Right? You're looking over there. It tricked me. Sorry. Where did they go? Yeah, Patricia's over here. My bad. There we go. Yeah. I think that was going to this X. Yeah. I think we need a starting point because it's the angles that make everything weird. All right. So we have 1 more X. All right, get out your tiles. You should have 12 ones, 4 X's. Go and set it up. We're going to have a lot of leftovers. Oh, man.
how do you work?
We have 4 X's. You are correct. making a perfect square. Okay, if you're done, don't forget we need the trinomial. What is the original tri with all these tiles? X squared plus how many x's, how many? And we're back. Good. All right, who can help me out? What is the trinomial for this? Trinomial is x squared.
Plus 4x.
It's just how many x's we have, how many ones we have. X squared is what we're starting with. So then, this is in standard form. I need it in vertex form. First, we need to set it up. So how many x's did we have? We have 4. So who wants to tell me how they set it up? 2 by 2, right? Good, thank you. How many x's are going to fit in this little spot? 4. So I'm just going to put 4. And then, what else should I do?
8 on the side.
8. Okay. Vertex form of this is going to be? Easy. Not bad. We're forcing the complete in the square, and then seeing what the leftovers are. And that's it. What number do you have to be to get Oreo cookie package? What's the? Yeah, I didn't tell you guys.
132.8.
Almost. You're gonna be 0.8. The 123rd subscriber gets a package of Oreos.
So if I make like 100 YouTube accounts, that's also right there.
You can. If you want to spend that time for Oreos, you can do it.
You actually give us Oreos.
Yeah. I gave the Kit Kat out, 4th period. Gabe won. Yeah. All right, 123rd gets Oreos. They're healthy, they're vegan. They're not healthy. They are vegan. Might be the same.